Hey everyone, and welcome back. Today we're heading onto the factory floor. And, you might be picturing sparks flying and old school assembly lines. But there's a quiet revolution happening. It's being powered by data, and it's teaching the machines themselves to think, to see, and even to predict the future.
It sounds like something straight out of a sci-fi movie, right? But this is the one question that keeps plant managers awake at night. I mean, a single unexpected breakdown can bring an entire production line to a grinding halt, and that can cost a fortune. So really, how do you stop a problem that you can't even see coming? Well, for decades, manufacturing has been totally reactive. You wait for something to break, and then you scramble to fix it. That's the old way, a cycle of expensive downtime and just, frantic repairs. But the new way? It's all about being proactive. It's about listening to the machines, using AI to translate their tiny whispers into crystal clear warnings. It turns a potential disaster into just a simple, scheduled maintenance task.
And let's be really clear about what's at stake here. Unexpected downtime isn't just some small inconvenience. It is a massive, massive financial black hole. And that's not all. You've also got this other silent profit killer, these tiny, hidden defects in products that just slip right through quality control. These two things are the big enemies that every modern manufacturer is constantly fighting.
And the solution isn't just to throw more people or bigger, clunkier machines at the problem. No, the real breakthrough is coming from making the equipment we already have way smarter. It's about embedding this new kind of industrial intelligence right onto the factory floor, and it's all powered by machine learning.
Okay, so let's get into it, because this isn't magic, right? It's actually a pretty methodical process. How do you actually teach a machine to predict a failure or spot a tiny flaw? Well, it all kicks off with data. Lots of data.
It follows this really clear pipeline. First, you collect just massive streams of data from sensors. Think of these as the machine's vital signs, its temperature, how much it's vibrating, even the sounds it's making. Then, and this part is absolutely crucial, you bring in domain experts who help extract the key features, turning all that raw noise into signals that actually mean something. With those signals, you train the model, feeding it tons of data so it learns the super subtle patterns of what's normal versus what looks like an impending problem. And finally, you have to validate it on new, unseen data to make sure it actually works in the real world.
But there's a classic trap here that everyone has to watch out for. It's called overfitting. This is where the model is basically a straight-A student on all its practice material, but then it fails spectacularly out on the factory floor. It's essentially just memorize the answers instead of learning the concepts. It's exactly like cramming for a test. You might ace all the questions you've already seen, but a brand new problem will totally stump you. Avoiding this is one of the keys to building a truly reliable AI.
So, once you've successfully taught this machine to think, and you've managed to avoid those common traps, what can it actually do? Well, this is where it gets really cool. It develops some incredible new capabilities. You could almost call them manufacturing superpowers.
We're going to zero in on 3 of the biggest game changers. First, the power of foresight. That's predictive maintenance. Second, the power of perception with nearly flawless quality control. And third, the power of efficiency, which just supercharges the whole production process. Let's just walk through predictive maintenance. So, picture this. A machine's running perfectly. Everything's great. Then the ML model, which is constantly listening, detects this microscopic change in vibration, a signal that's totally invisible to any human. The AI sees this trend and it predicts, hey, there's a good chance of a bearing failure in the next 72 hours. An alert gets sent, maintenance is scheduled for a slow period, and bam, a massive production-stopping breakdown is completely avoided.
Okay, so that's incredible for keeping the machines healthy. But what about the health of the products they're making? Well, that's where the next superpower comes in, using AI to reach a level of quality control that was, honestly, just unthinkable before.
I mean, just look at this number. The accuracy is just staggering. In one study on casting products, a deep learning model hit a 99.86% accuracy rate at identifying defects. Now, to put that in perspective, a manual human inspection? That usually tops out at around 80%. This isn't just a small improvement, it's a complete transformation of quality control.
And that third superpower is just a huge boost to productivity. By looking at all these different variables, machine learning models can accurately predict how long certain processes should take. This gets rid of all these tedious manual time studies and lets managers schedule things way smarter, cutting down on bottlenecks and idle time. The whole factory just runs faster and more smoothly.
Okay, this all sounds amazing, but it leads to a really big and honestly a very fair question.
If the AI just spits out an order, like replace this part or reject that product, with zero explanation, how can an engineer or a manager really be expected to trust it? This is what everyone calls the black box problem.
And this is a major hurdle, because for this technology to really take hold on the factory floor, it's not enough for the AI to just be right. We have to understand why it's right. We've got to crack open that black box.
It really boils down to this powerful idea. An answer from an AI is only useful if we can understand how it got to that answer. You know, trust is everything here, and trust requires transparency. It's as simple as that.
This brings us to a super important concept called model interpretability. This is a whole field dedicated to creating tools that let us peek inside the model's brain, so to speak. The whole goal is to turn that opaque black box into a transparent glass box, where all the reasoning is out in the open for us to see. And this isn't just theory anymore. We have tools that can do this right now. Techniques like SHAP can take any single prediction and break it down, showing you exactly which data points push the decision one way or another. So for that failure prediction, it might show an engineer, hey, that high vibration level, that was a huge positive driver. The rising temperature, a moderate one. But the motor current, nah, that was actually fine. This gives them real, understandable evidence to back up what the AI is saying.
So when you put all of these pieces together, the predictive power, the superhuman quality control, and this new level of transparency, you start to see the much bigger picture. This isn't just about making one machine a little bit better, it's about building a truly intelligent, interconnected factory.
And this is exactly what all the experts are talking about when they use the term Industry 4.0. It's the fourth industrial revolution, and it's all about fusing the physical world of manufacturing with the digital world of data, analytics, and of course, artificial intelligence.
So, let's just do a quick recap of the big takeaways. Machine learning gives factories the power to predict the future, stopping failures before they happen and saving a ton of time and money. It ensures top-notch quality by spotting tiny flaws with almost perfect accuracy. It boosts efficiency across the board by optimizing workflows. And, so importantly, these new tools are building the trust we need for people to actually use it by making the AI's logic totally clear.
And this all leaves us with one last, really fascinating question to think about. As factories and all the machines inside them stop being just simple tools and start becoming intelligent partners that can predict and diagnose and optimize all on their own, what does that mean for us? For the people who work there? What's the new elevated role for human creativity and strategy and ingenuity? That's the exciting new world we're just now beginning to explore.